Okay, if you were just watching the last video, which hopefully you were, you realized it cut off strangely right at the end in the middle of my talking. I don't know why. I'm in the middle of videotaping and I just looked over and it somehow cut off. So I'm going to continue where the last video ended. And in the last video we ended talking about the domain of a function, and we said there's a domain in the range, and we're going to forego talking about the range right now and only worry about the domain. And as far as it goes for a definition, the domain of a function is all the x's that go into your function. And a lot of times, to actually find the domain of a function, the way we find it is not by seeing what goes into the function, but by looking for things that can't go into it, and then we define our domain that way. So the idea is, if you have something like this, y equals 2x plus 3. If you recognize that, that's the equation of a line. If you don't, or if you're kind of vaguely aware, we'll go over more of that later in this chapter. But just trust me, that's a function. If I plug in 1x, any number, I'll get a y out. So it'll be a function. If I want to find the domain, I say, are there any x's that cause a problem? But if you think about it, if I plug in a positive number, any number you can think of, I can multiply it by 2 and add 3 and I'll get 1y. So the positives will work. If I plug in a negative number, I can multiply that by 2, add 3, and I'll get a y. If I plug in 0, I can multiply that by 2, add 3, and I'll get a y. Which means no matter what x, whatever number I plug in, I can get a y out. No x's cause a problem, which means my domain is negative infinity to infinity. All real numbers. If you want to be cool, you draw this little R-like thing right there. That's how we say all real numbers. So suppose I look at something else. Y equals x squared. That's a quadratic, like we were just dealing with at the end of the last chapter. And we can do the exact same thing. If I want to find the domain, I look for x's that don't work. But if I plug in a positive number, I can square a positive number, so that'll be fine. If I plug in a negative number, I can square a negative number, so those will be fine. If I plug in 0, I can square 0, and that'll be fine. Which means, again, there's nothing that causes a problem. So to my domain will, again, be negative infinity to infinity, which is all real numbers. And that you kind of tend to believe, after looking at a few of these, that your domain is always all real numbers, which kind of makes it pointless to actually think about it. But there are a few problems that can occur with other functions, and we want to look at those right now. So I guess we'll just start with problem 1. So first, suppose I have y equals 1 over x. Again, trust me, if you're unsure, this is a function. No matter what x I plug in, I'll get 1 over x, which will be one number, which will be my y. So each x will give 1y. And then I say, are there any x's that cause a problem? Well, if I put in a positive number, 1 over a positive number is just a fraction, so those are completely fine. If I plug in a negative number, I just get 1 over a negative number, which is a negative fraction. Those are fine. If I plug in 0, though, I get 1 over 0, which doesn't work. I'm not allowed to divide by 0, which means in this case, 0 doesn't work. So now I actually have a problem. I can't let x equal 0. So then when I do my domain, I can't say all real numbers anymore. So now I have to say negative infinity to 0, open, because I'm not including 0, union 0 to infinity, because I want all the numbers except for 0. If you wanted to do it in set builder notation, you could do the set of all x's such that x is unequal to 0, because you want all the x's except for the one where it's 0. So suppose I have this then. Y equals 3 over x plus 2. Will I have a problem? Well, up here I have a problem because when I made x 0, I got 1 over 0, which doesn't work. Here, if I plug in x equal to 0, I get 3 over 2, which is fine. But if you think about it a little bit, there's still more than likely some x I can plug in that will make the denominator 0, which is a problem. Here it's pretty obvious. If x is equal to negative 2, I'll get 3 over negative 2 plus 2, which is 3 over 0. which tells me now negative 2 will be a problem, because that's an x that will make this thing undefined. So then for my domain, I can't include the things that cause a problem, so my domain is negative infinity to negative 2, union negative 2 to infinity. If you're kind of getting the idea, then maybe we'll just use this one. Y equals 3x plus 4 over 7x minus 5. And clearly now, based off of these, we kind of get the idea something is going to cause a problem. As far as it goes, the numerator is irrelevant. You don't even have to worry about it. I can have 0 in the numerator of a fraction. That's just 0. That's okay. The problem is down here. And here, I couldn't let x be 0 because that made the denominator 0. Here, I couldn't let x be negative 2 because that made the denominator 0. So now I have to find some x, if there is one, that will make the denominator 0. If there is an x that does that, then I can't include that x. And the actual trick, since I don't want the denominator to be 0, just set the denominator to 0 and solve. Any x's I get are x's that make the denominator 0, so I don't include them. In this case, add the 5, divide the 7. That's the x that will make the denominator 0, which means that's the x that causes the problem. So then for my domain, that's the x I don't include. So I'll go negative infinity to 5/7, union 5/7 to infinity. So all you really have to do is take your denominator, set it equal to 0, and solve. That's the first problem. There's one other problem that we want to look at that can occur with my domain. And we'll call it, not surprisingly, problem 2. So suppose I have y equals the square root of x. Again, if you're not entirely convinced, just trust me for now. We're going to spend more time studying this one later. That is a function. Any number you plug in, when you square root it, you just get one number, the square root. So it will give me a function. Then I say, what's the domain? And if you think about it, if I plug in a positive number, can I square root it? Sure. You may get some bizarre decimal that you don't know off the top of your head, but you can throw it in your calculator. You'll get an answer. If you plug in 0, you can get the square root of 0. It's 0. But if you plug in a negative, you get the square root of a negative, and that we know causes a problem. We remember from the last chapter, if you have the square root of a negative, something like the square root of negative 2, that becomes root 2i. And you get this complex number thing. Here, when we're talking about functions, we're talking about real valued functions, functions with real numbers, which means I can't do the complex number thing. So, I can't let x be negative, because if it's negative, then I'll have a complex number which I don't want. So the domain for this, let's see, 0 is okay, and then all the positives up to infinity okay. Here again, make sure you know the difference between open and closed. This is closed at 0 because I want to include that. But then, suppose I have y equals the square root of x minus 6. Well, now we kind of get the idea, much like with the fractions, that there's probably some x that will somehow mess with this. And if you think about it a little bit, if I make x like 10, I get 10 minus 6, which is 4. I can take the square root of that. If I make x 5, I get 5 minus 6, which is negative 1. I can't take the square root of negative 1. So clearly, some x's will work and some won't. We just have to figure out which x's work and which don't. Here, it's kind of probably obvious. If x is equal to 6, I get the square root of 0, which is 0. Anything bigger than 6 will give me a positive number. Anything smaller than 6 will give me a negative. So now my domain goes from 6 to infinity. But then suppose we kind of up the difficulty one more time, and we get the square root of 2x minus 5. I know from these, Clearly there's going to be a problem with my domain. I just have to figure out what it is. And the trick is actually, for this one right here, I needed that x to be greater than or equal to 0. For this one right here, I needed to find the x's that would make this greater than 0. So for something like this, when it's kind of messier and not obvious, all you have to do is take whatever is inside the radical, and since you can only take the square root of things greater than or equal to 0, set it greater than or equal to 0 and solve. Add the 5, you get 2x is greater than or equal to 5, divide the 2. X is greater than or equal to 5 over 2. Now, those are all the x's that will make this greater than or equal to 0, so there's my domain. 5 over 2 to infinity. There are other ways to do this, but for right now, these are the only two things we're really going to concern ourselves with. Kind of problem 1, we have a fraction with an x in the denominator, set the denominator equal to 0, and then any x's that make the denominator 0 are the ones you don't include in your domain. Or the second problem, a radical with an x inside of it. Take whatever's inside the radical, set it greater than or equal to 0 and solve. That turns out to be your domain. There's one or two more things I want to go over from this section in your book, but this video is long enough and it's actually part of the other video. So I'm going to stop this and I'll just do one more video for the rest of this section.